Thank you, everyone, for joining us. We are so pleased to have you join us for the final webinar in our series, A Targeted Approach to Reducing Environmental Cancer Risks in Pennsylvania. My name is Andre Green, and I'm super excited to be your co-host today. I serve as the Associate Director of the Cancer Environment Network and as an at-large member of the Environmental Health Working Group with the Pennsylvania Cancer Coalition, whose primary and central objective is to strengthen public protection from environmental carcinogens and cancer risk factors. This entire series is a collaborative effort between these two organizations that I am honored to represent. Specifically, the Cancer Environment Network is a collaborative hub of about 50 organizations collectively dedicated to creating a future where people are no longer exposed to toxic chemicals that contribute to cancer. Now let's turn our attention to today's speaker and topic. We are incredibly fortunate to be joined by Dr. John Stoltz, professor in the Department of Biological Sciences and Department of Civil and Environmental Engineering and Science at Duquesne University. Today, John will discuss the critical topic of ensuring safe drinking water for all Pennsylvanians. Today's session will explore common carcinogenic contaminants found in drinking water. We will also work to demystify the differences between primary and secondary water standards. And with that being said, thank you so much for being here, John. The floor is yours.
Great. Thank you very much, Andre. Thanks for that introduction. I'm going to share my screen. And okay, if I can get out of there. All right, good. Can you all see that?
Yes.
Okay. So the topic of today is ensuring safe drinking water for all Pennsylvanians. This is an example of a watershed. This one happens to be Buffalo Creek in Washington County. As you can see off to the side here, you can see my cursor there. That's Washington, the town of. Okay, let's see what we're doing here. Oh, I got it. Okay, so what is it there to be concerned with our drinking water? The purpose of this presentation is going to try and address some of these questions. Where does it come from, your water? Is it public water or private well water? Who assures the quality or regulates it? Is it the US EPA or the PADEP or anybody? And what are the threats to our water resources, and what can we do to protect our water? So just a little background, timeline of events of environmental legislation. I grew up in the 60s, and so I was one of those folks, young at the time, but we had problems with our water quality and our air quality. I grew up on Long Island in New York, and we had a lot of pollution in New York City. Again, I would say, and I'm hoping that we're going to have a renaissance, if you will, in environmental stewardship with the Artemis project. But why I mentioned that, we just went around the moon. It was 1969, the landing on the moon by our astronauts that really brought home this whole idea that we have this planet and it's a little blue marble in the middle of a black abyss, and that this is all we have. And it literally galvanized an environmental movement that resulted in a lot of environmental legislation. And I can even say that it was Richard Nixon that was part of some of this legislation. So I just want to point out a couple of things. There was the 1972 Clean Water Act, and then more importantly and significantly, the 1974 Safe Drinking Water Act, which basically set standards for drinking water. And then later on, there were other additions to that that kind of addressed some emerging concerns. But the fact of the matter is that this Environmental Protection Agency was created to safeguard our environment, our drinking water, and our air quality. And then I have a few more things that I wanted to point out that are now actually a source of concern, and I'll explain why. And one of them was the 1976 Resource Conservation and Recovery Act, which, due to the Benson Amendment, he was a senator from, Lloyd Benson was a senator from Texas, it defined oil and gas waste as non-hazardous. So this waste has now found its way into our landfills, our sanitary landfills. And we'll talk a little bit about that. And then, of course, more recently, in 2005, the Energy Policy Act, which essentially exempted fracking, or this unconventional development of oil and gas reserves, using high pressures and chemicals and a lot of water in underground injection, from the Safe Drinking Water Act, as well as underground injection and storage of natural gas. So again, these have repercussions for today. Um, for now, just to, we have two main sources of water other than bottled. We have our public water authorities, PWSA, for example. I live in the North Hills of Pittsburgh, and so my authority is the Hampton Shaler Water Authority. Um, and those major water authorities are under EPA regulations, and they have to file quarterly reports. So this is an example of one. This is a water quality report from the Baden Borough. Just happened to, you know, have it on hand. But you'll see that there's a number of things. There's some abbreviations. There's some other things. But we're looking at what are they testing for? They're testing for chlorine. They're testing for, and we'll talk about these, disinfectant byproducts, namely trihalomethanes. There's also haloacetic acid, which is another. Why are these things of concern? Because in many cases they do cause cancer. And then you have some of the heavy metals like lead and copper. And of course, if you look at the bottom of that page, nobody wants cyanide in their water. Um, Again, one of the things that we're concerned about, again, and this is also on that additional page, this is on page 3 of this report, are the trihalomethanes, because they're things like chloroform and bromoform. They are the result of the chlorination step in disinfection before the water goes out into the pipes for distribution. And they're cancer causing. And as I said, they are regulated by the EPA. So what are these EPA standards? Well, it turns out there's actually two sets of standards. They're the primary standards and the secondary standards. The primary standards are specifically for water treatment and public waterworks that are providing a number of people. I believe the cutoff is about 3,000. But again, it depends on the facility in question, but most public water authorities are under the EPA guidelines and the primary drinking standards. These are compounds or elements that are known for their toxicity, whether it's cancer or other negative health outcomes, but they're things like antimony and arsenic. And they've set a level, so the water authorities have to test for these things. And then and have to deal with them if they are not in compliance. Then there are the secondary drinking water standards, which are not enforceable, and they're considered cosmetic because they cause things like discoloration. It may be taste, odor, or color. But I always, when I started getting into this area, I was rather intrigued by the fact that we're looking at things like chloride, we're looking at things like fluoride, iron, manganese, sulfate, total dissolved solids. Specifically, things like sulfate, manganese, and iron, we associate those elements with extractive industries. So the combination of these things, but these are non-enforceable. So that poses a problem in itself. And now, as I said, some of the science in this, we now know that manganese can be as potent a neurotoxin as lead, which is on the primary. All right, so what's in your water? And a few little scientific things. Conductivity is a measure of dissolved materials. Water itself doesn't really conduct electricity, but the more stuff you put in it, and especially different anions and cations, or things that are negatively charged and positively charged, they increase the conductivity of that water. And that's one of the means that we actually use. We have a little probe that's, we measure conductivity of a sample to give us an idea of how much is actually in that water sample. And from that, we can also get an indication of total dissolved solids. Obviously, you don't want to be drinking distilled water uh, or deionized water because there's nothing in it, and that's bad. But you also don't want it to have a lot of different things in it. You want to have electrolytes in it at a certain level, but you also don't want too much. So we're looking at levels of about 200 to 300 milligrams per liter. pH is a range of hydrogen ions, and it's on a log scale, but essentially the EPA standards are between 6.5, which is on the acidic side, to 8.5, which is on the basic side. But again, those are the parameters there. Alkalinity is a measure of buffering capacity. Hardness is the mineral content and typically calculated from calcium and magnesium. You've probably heard that a lot of places around here have hard water. Total organic carbon, you don't want stuff in your water because it's going to lead to microbial growth. And then, of course, methane. And there's two flavors of methane. One is biogenic, the other's thermogenic. Simply put, biogenic is what you find if you stand next to a cow. They have microbes in their rumen that produces this. You can also, it's also called swamp gas because they're the same organisms are living in lake sediments, lake bottoms. And then the thermogenic is stuff that has been produced over millions of years in these rock formations that we're now fracking called shale. And so that is from basically we're talking about things like oil and gas wells. So thermogenic methane comes from oil and gas wells and from coal bed methane. Some of the other nasties, coliforms, are just another term for fecal bacteria. So you don't want to put, if you have a private well, you don't want to put it anywhere near your septic. And of course, when we talk about things, it's another amazing thing that I found out when I moved here to Pittsburgh so many years ago. That our wonderful rivers are not only where our wastewater treatment plants discharge their waste, our processed water, but it's also oftentimes the intake of our drinking water. So we don't want to get fecal bacteria in our drinking water. And E. coli or Escherichia coli is a common bacterium, human bacterium. We all have them in our gut. So these are things that we also have to be aware of. And those, as I said, are regulated as part of the primary standards. So again, there's the primary standards, there's the secondary standards, which are non-enforceable. And then the last one, THM, is trihalomethane, that's chloroform and bromoform, and we're going to talk about that in a little more detail. And then the other thing is we have yet, when I was a kid in the 60s, we were going to go metric, right? Do you remember that? Some of you older folks. We never did. But the scientists did, and so and even the water quality people. So it kind of you have to know the vernacular. I mean, the oil and gas industry still talks about barrels, but anyway. So MCL means maximum contaminant level, and those are the levels set by the EPA. So something like arsenic, the maximum contaminant level or MCL for that is 10 parts per billion, and then we have the metric. So milligrams per liter is parts per million. Micrograms per liter is parts per billion. So again, getting back to 10 parts per billion, that's 10 micrograms per liter. If you have had your water tested by, and it's a private water well, for example, you may also be introduced to some of these other abbreviations. These are typically used by our Department of Environmental Protection. So if you had them test your water at your home, and you would see that they'd have these different things. So U, the analysis performed but not detected. J, it's an estimated value, detectable but not quantifiable. N is a presumptive evidence of a compound. B is the compound was found in the blank. This is a flag that should go up, that anytime, typically when we test water, we will also test water in our own lab because we want to make sure we haven't introduced any contamination by doing what we're doing. And this does happen, and that's why we run what's called blanks. There's trip blanks, there's method blanks, but these are basically controls to make sure that we haven't messed up with our sampling and analysis. E is another concentration exceeds calibration. This is one of my bugaboos. If you send your sample off to a commercial lab and it comes back with E, it means that there was something in that sample that didn't fit their standard curves. So you can't just calculate based on what you think is there. So there's some, and if there's interest in talking about those problems, we can do that later. Um, and the last one that I'll talk about is the MDL, which is the method detection limit. So in other words, we use standard methods. EPA actually has a set of standard methods that they require any commercial lab to use if they're certified. So that's an important parameter to understand. So they have to use specific types of equipment with specific detection limits so that you don't want to use a method or a piece of equipment that isn't sensitive enough to measure something at the maximum contaminant level because everything will be beyond your detection limits. And this is another one of my bugaboos. But anyway, okay. All right, so let's look at some of the problems. So what do we mean by disinfectant byproducts? Well, when you're making water, you're taking your source water, you're putting it through various filtrations, settling tanks, and things like that. You may be doing some aeration and some other treatments. You might do reverse osmosis, depending on what the facility has. And then eventually it has to go, into the pipeline for distribution, and they put a little stuff in there. It's either they will chlorinate it, so many times you'll open your tap and you'll get this whiff of chlorine. And then another method is chloramination. Well, both of those processes of treatment or disinfection have contaminants. Chlorination, if there's bromide and residual organics, they will form these trihalomethanes, such as chloroform, bromoform, etc. So you'll see in the lab report from the Water Authority, they call them TTHMs, or total trihalomethanes. And the maximum contaminant level for that is 80 parts per billion. Now, here's the rub. Parts per billion per quarter, but the authority only has to report if they're out of compliance for trihalomethanes if they are out of compliance for 4 straight quarters. So if you do the math, that's a year. So your facility could be out of compliance for over a year before they have to notify you. The other thing is they just need one good quarter. And so, the rainy March, their levels of trihalomethanes may be below the threshold, so they're good for the rest of the year. Chloramination rather. Let me back up. All right, so the presence of either trihalomethanes or haloacetic acid can lead to bladder, rectal, and colon cancers. Not good. So alternatively, what authorities have been doing is switching to chloramination, which is pretty much as good. But if you don't put the right, and believe it or not, another additive that goes into your water are what are called corrosion inhibitors. And if you don't put the right corrosion inhibitor in, chloramination could lead to lead leaching. And this was a big problem in the DC area many, many years ago when they switched, and there was a massive outbreak of lead in the drinking water in the greater Washington, DC area. Okay. So what's the connection now? And now I'm going to go into why I feel that, with all this new, or it's been over 15 years now, but with the oil and gas development and the shale boom, we've been having trouble with the shale waste, both the drill cuttings and other materials, because we know they're radioactive and they have chemicals with them. Where is that going? And we'll talk about that and why it's important to our drinking water. And then, of course, the produced water that actually comes back up the hole as the gas well or oil wells in production. And it's because it's a brine and it has a lot of chloride, it has heavy metals, but it also has that bromide. And so this is an article from the Post-Gazette that came out in 2011. bromide, a concern in drilling waste water. And the point is, back then, they were actually allowed to take their brines directly to public wastewater treatment plants. And what was happening is that the salinity of the three rivers was increasing, but also there was increased bromide and residual organics in the water system. And so places like the Pittsburgh Water and Sewer Authority, they were having issues, because what was happening, and it says here, bromide facilitates the formation of brominated trihalomethanes known as THMs. Okay, so now so Stanley States from the Pittsburgh Water and Sewer Authority said, we have a problem. Okay. Again, Marcellus wastewater shouldn't go to treatment plants. A lot of our municipal water authorities, and with good reason, because they were getting 6 to 6.5 cents a gallon for this stuff, and they didn't have to, charge the ratepayers. They were seeing. I visited the McKeesport facility, and the manager of the plant was anticipating over $2 million worth of new revenue, and they were going to expand and they were going to do all these improvements, which is great. But on the other hand, they were indeed sending more bromide into the system and causing downstream issues with the drinking water facilities. So how did the water authorities comply? Well, they switched, which of course came at a cost to the ratepayer. So we see here water company plans to change disinfectant used in some systems. So places like New Sewickley, Westview, and Brackenridge. That's how they dealt with the issue. But now you open up the possibility and you realize how much the PWSA, for instance, has spent over the last several years just to get the lead lines out. Because it turns out in the 60s, there was actually a move by some lead pipe organization, to replace a lot of those copper lines with lead lines. So we have a legacy of lead pipes in our city. So that, thankfully, a positive outcome more recently is the fact that those things have been replaced. But again, with the switching to chloramination, we've run the risk of increased lead contamination in our drinking water, our public drinking water. And then the last thing is, and this is another a study that just came out of the water group at Pitt, Emily Elliott and her folks, in 2018, again, I'm assuming as a response to issues with their source water, the local water authorities have switched from caustic soda as a corrosion inhibitor, now to orthophosphate. And the problem with that is that they say that they lose anywhere from 40 to 50% of the water they put in the pipeline. Well, that's now causing a process called eutrophication in our local streams and rivers. So again, dealing with this. This is an example of a violation. This was for Charleroi. This was the one that got my interest. This was dated in 2015. Getting back to that situation where we were originally allowing the industry to bring their wastewater directly to the wastewater treatment plants, that was suspended in 2012 under the Corbett administration and later codified by the US EPA. So it was kind of a puzzle to me. I thought we had solved that problem of the trihalomethanes due to the brines coming from the oil and gas industry, but still certain water authorities were having problems. And why would the Charleroi facility have a problem? Well, it turns out we have a lot of landfills that are accepting oil and gas waste. So this is a map from Frac Tracker for what was happening back in 2022. It really hasn't changed, but here's that connection. So it turns out we have all this waste at the well pad. We've got brine and drill cuttings. Well, it's going to landfill, and landfill produces a wastewater called leachate. And I would call your attention to that bottle on the right-hand side in the center there. That is leachate from the Westmoreland landfill. And if you would have opened that container, it would smell like oil. And they had taken so much waste that it impacted the quality of the leachate. Well, where was that leachate being treated? It was going to the Bell Vernon wastewater treatment plant, which is in the lower right-hand corner. And guess what? It was discharging into the Monongahela, and who's just a few, not even 2 miles downstream? The Charleroi Water Authority. So the whole point is drinking water concerns addressed in Valley. This was back in 2016. Um, it took a court order to stop the Westmoreland landfill from sending their wastewater to their leachate to the Bell Vernon sewage plant. I actually got, that's a sample that I've analyzed and whatnot. Here's why, and here's the connection. So that leachate had high chloride, it had bromide, and it had radium 226 and radium 228. And when I got my sample, I got a call from the manager of the plant at the time. He said, "Would you please, help us out here?" And I said, "Okay, I'll take some samples and we'll analyze it." The specific conductivity and total dissolved solids were above their discharge. But more importantly, they were definitely discharging chloride and bromide and radium 226 into the Monongahela River. Now, that was prior to the injunction. Post injunction restraining order, I went back, and guess what? The facility was back in order, and the Charleroi Water Authority was happy again. More importantly, the discharges from these wastewater treatment plants treating the leachate are still discharging radioactive radium. And this is a paper that we published back in 2023, where my student Lauren went and looked at all the manifests that she could get her hands on, looked at all the DEP records. We discovered that over like 800,000 tons of oil and gas waste was unaccounted for in Pennsylvania because the manifest didn't match up with what was actually reported to the DEP and vice versa. So it was very, very unfortunate. The other more important thing was that when there were certain certain wastewater treatment plants that we were able to access sediment upstream and downstream from their discharges and found statistically significant higher levels of radiation downstream than upstream. And that's because radium is sticky. So when it's released from these facilities, whether directly from the landfill or from a treatment plant, it sticks to the sediment and eventually increases. And we're not the only ones who have shown this. This is a study that was done by the Penn State group, sources of radium accumulation in streams downstream of disposal sites. And this is actually from licensed facilities to treat conventional brines. So again, it's impacting our water resources. And if that weren't bad enough, this is those vertical lines there are horizontal wells. They're both Marcellus and Utica wells, crisscrossing the Beaver Run Reservoir. And the fact of the matter is that they had an event several years ago, you might remember, but CNX was fracking a Utica well underneath the reservoir, and they had a casing failure. And as a result of the casing failure, it pressurized a conventional or an older well reserve or gas reserve, and they had to basically flare 9 shallower conventional wells to prevent blowouts. But this is in the reservoir itself. And now we understand that there's been more requests for drawing more water from the Beaver Run Reservoir. And then my last story, and this is the one that has to deal with private water wells. Because again, there's over 3 million private water wells in Pennsylvania. And the big problem is that we are one of 2 states that don't regulate well water, or I should say water well construction, nor mandate any routine testing of the water quality from those wells. So normally what can happen is if something does change, and usually it's the change in color, smell, or taste, which is what happened here in New Freeport back in 2022, um, that there's no recourse because people don't have quote unquote pre-drill. So in other words, when the drilling company is going in and drilling and fracking, um, typically they now will test people's water wells within 3,000 feet of the well pad. Well, let me explain what happened here. So there was a report. Turns out I got contacted. There was a family. The one kid was taking a shower and came out and had rashes, and they didn't know what was going on. So the mom went and opened up the Facebook page and saw this notification. And this is this is a screenshot from the Facebook page. To all residents who live on Main Street in the fire hall west to Harrods Run, there's been a frack out at the bottom of Fox Hill. All drilling has stopped for now, and I do not know what will happen, but suspect it will be in the next few days. If you smell gas or have discolored water, do not drink or use. Contact this, da 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 da. Well, the picture on the right, which is what I took, is that's what happened. So here's the amazing thing. They were fracking a Marcellus well at 7,800 feet depth. All right, so almost 8,000 feet below the surface. They were 6,000 feet from the well pad. And fluids from the fracking somehow breached containment and communicated, they call it a frack out, communicated to this abandoned conventional well, 3,000 feet away. And as you can see, the fluids came all the way up to the surface. So this thing here, this is the old well. So this is where the casing was. It's gone. And what we've done, and we've actually published this now, these are the different, there are quite a few well pads there, but it was the lumber well pad. And so this is where the fracking was being done. This is where the abandoned well was. And what we were able to do was go and over a 2-year period, test the well water from a lot of different people. We had over 90 samples, but for the report, we had 75 total well samples that we used to do our analysis. These are the chloride levels, and you can see where a lot of the big circles are. So this is where the well pads are the purple circles. And what that purple circle is, by the way, the diamonds are the well pads. The purple circle is what we call the zone of presumption. And I'll talk a little bit about that. But you can see that there's contamination well away from these well pads. Now, what is the zone of presumption? The zone of presumption is a DEP guideline that says if a drilling company if something happens to your water well and you're within 1,000 feet of a conventional well or 2,500 feet of an unconventional well, that you can request the company to provide you with an alternative source of water of quality and quantity. Okay, that's the regulation. Well, as you can clearly see from here, a lot of these impacted people were well away from where the actual drilling and fracking was occurring. This is actually methane, and unfortunately, there were quite a few homes that unfortunately had unsafe levels of methane, and at least 2 that had explosive levels of methane in their private water well. And again, getting a little chemistry-wise, this is what we do with our water data. We look at things like calcium, strontium, magnesium, and we look at the chemistry, we look at the methane. But I hope you can see in this graphic, the stars are all our well water samples. And the numbers next to those well water samples actually turn out to be the amount of methane. Anyway, you can, if you're good at these things, you can actually see that there are not 2 clusters, this one and this one down here. And this cluster of water well samples, because of both their location and the amount of methane in their water, we would say that they were impacted by this event. And what these larger things, because years ago we went through, my colleague Dan Bain and I we went through a lot of different parameters and came up with these ratios. Um, and we can see MD is mine drainage, CG is conventional gas, UG is unconventional gas, CO is conventional oil. Um, this is based on a lot of different samples and databases, etc. But anyway, we use these plots to see whether or not we have presumptive evidence that someone's well water was uh, contaminated. And we also had put together a number of different parameters that we call it our multi-parameter contamination index. And you can see that according to our analysis, a lot of these homes now have contaminated water that have been impacted by oil and gas development in New Freeport. And this is their relationship to the different well pads. And this was published last September in Scientific Reports, which is a peer-reviewed international journal. Okay, so that wraps up the story on that. So we're talking about private wells and public water being impacted by oil and gas development. And then lastly, the emerging elephant in the room is PFAS, and I don't have too much to talk about that. But again, PFAS are per and polyfluoroalkyl substances. There are over 9,000 chemicals, Teflon, nonstick coatings, fire retardants. They've put it into everything. And I was just at a meeting and forum in Marietta, Ohio, related to injection wells, which is another total story, but found out that Parkersville, West Virginia, is one of the sites that their drinking water is contaminated with PFAS because of DuPont activities down there. Most people in the United States have been exposed to some PFAS. People can be exposed to PFAS by touching, drinking, eating, breathing in materials containing it. This is from an EPA website that still exists, thankfully. But you can see the first one, drinking water, an important potential source of PFAS exposure. Okay. And then are they safe? Well, they can cause cancer. They can cause weight effects, immune effects, developmental effects. So again, this is another threat to our drinking water. And is there a connection? Well, of course there is. And this was a report that Physicians for Social Responsibility, PA, did, fracking with forever chemicals in Pennsylvania. So it's even in the fracking secret sauce. So last thing, what should we do? Well, you can get, if you have a private water well, you can have it tested. If you are drinking public water, contact your water authority. And if you haven't gotten their latest newsletter, get it and see what their results are, see how they're doing, see if they're in compliance, if there have been any violations. But be nice and talk with them because they like to hear from people. But what are we testing for? Again, pH, conductivity, chloride, bromide, fluoride, nitrate, nitrite, phosphate, sulfate, and a whole suite of metals. And then, of course, with the light hydrocarbons, especially for a private well, methane, ethane, ethane, and propane. And the reason being is that methane by itself is typically biogenic, meaning swamp gas or whatever. But if there's these other complex, more larger hydrocarbons, it's an indication of a thermogenic source, namely from an oil and gas well. So what can you do to protect your water? That actually turns out to be an EPA program called Source Water Protection. And it's actually administered by our own PADEP. So this is one that was being done for the Ambridge Reservoir and Aliquippa. People got organized. They talked to their water authority and their wastewater authority. They were able to hire, through this process, a hydrologist that was able to tell them where their water was. So for instance, even though the Aliquippa Water Authority is not drawing directly from the Ohio, they have a deep well. It turns out that 70% of the water that's going into that deep well, that's feeding that deep well, actually comes from the Ohio. And what they were able to establish was that there were certain businesses that were actually on critical areas of recharge to their what we call aquifer or subsurface water sources where they were getting their water from. And so, again, they were able to take some preventative actions to prevent contamination to getting into their water supply. So this is something that you can do and, reach out to the DEP to ask about that. So with that, I will say thank you, and I'll stop my screen sharing and open the floor for questions.
I know that we have a question in the chat. Let's see. Yes, from Ned. So Ned asks, what are some things that DEP/EPA are not testing for in our water that we should be ordering whenever we test drinking water?
That's a good question. And I think, well, I mean, and again, so with the situation with the PFAS, right now my understanding is that regulations are in negotiations. So if you're worried about PFAS, and again, it depends on where you're getting your water from. So, but good question, Ned. And thanks for being in the room.
You know what? I'm glad to be here. How about radioactivity, especially from, from a well? Is that something that I should be making sure that they test? Can they test it?
Well, and that's an interesting question because I meant to mention that. So in principle, and just as a matter of context, I just resigned from because I'm going to be retiring soon. But for the last several years, probably 15 years or more, I've been on the Laboratory Accreditation Advisory Committee for the state of Pennsylvania, which sets the rules for certification and other things. So we get the heads up on these new regulations. But it turns out that your typical, unless there's a reason to, so for instance, if you're a water authority downstream of 3 Mile Island, you have to test for radioactivity more regular. But typically it's every 9 years. So unless there's a reason to, you only have to test for radioactivity every 9 years. And if radioactivity shows up, then that goes to every 3 years. And then if after 3 years it doesn't show up, then you're on a 6-year term. And then you're back to 9 years. So yeah, no, because again, the question has been why, and even our landfills were not required until recently, and even that's still up in the air. So back in 2021, the Wolf administration, to address the concern of the radium in the landfills, started requiring landfills to report quarterly on radium-226 and 228. However, the DEP put a deferral on that in order to do their own study, which was just released 2 weeks ago. And that's a whole nother story because they literally, without doing risk assessment, concluded in their press release that this wasn't a risk and therefore something not to be concerned with. So yes, Ned, if you are downstream, I would suggest, it's worthwhile. But again, make sure that the company that's testing for it knows how to do it, because that's the other thing. There are 3 EPA approved methods. The 901.1, which uses gamma spectroscopy. Again, this is getting technical. There's the 903 and the 904. The latter two require precipitation of the radium with a chemical, but there's interferences. And the point is that these methods are approved for finished drinking water, not crude wastewater or even raw water. And there's problems because there are interferences, and especially with something like barium, which is, anyway, long story short, make sure the company that you're having doing the testing knows what they're doing.
Thank you. We have a question from Yesh.
That it's all and during the beginning of this presentation, you shared a water quality report that contained a list of toxins and the quantities in which they were present. My question is that are these reports available for all the counties? And if so, are they available online or
Good question. And in many cases, yeah, you can go to the Water Authority's website, and they usually, like, because they're saving postage, they'll post them. But if you don't find them or they're not readily available, then I would reach out and contact the authority directly and request them, because they have to by law provide them, because they're under EPA regulation.
and you?
I think we got another question in the chat from Kayla. She asks, is there a list of labs or recommendations of where we can get our water tested?
That's a good question. Right now, unfortunately, I would shy away from any major uh, large testing labs, because again, what's happened, there's been a lot of consolidation in the industry. I won't name names, but the one in particular just published, just purchased specialty pathogens. And that was a facility just down the street from my office here at Duquesne. And their specialty was Legionella. And now they've been bought out by this much larger. So what happens is somebody will come and collect your water samples, but your samples will be shipped all over the state, and in some cases all over the country, depending on what they want to test for, because now they have specialized units. That's not really good, because you don't want your samples sitting around for any extended period of time. And the DEP actually puts limits on that as well. But they're I would say they're very not liberal limits. We know for instance, the light hydrocarbons, if you don't test them within 24 to 48 hours, you're going to get much lower results. So find a small company that does a lot of different things that you can trust.
I actually have a question for you, John. So particularly during the end of your discussion when you talked about the Pennsylvania DEP Source Water Protection Plan, I started to think about what are some other tangible ways that we could protect water quality in our homes. And I started to reflect on just like general water pitchers that people will purchase. So in your expert opinion, does home like water filtration, like having a pitcher filter, provide enough protection against these carcinogenic contaminants that you discussed?
Another good question. And I'm happy to report that activated charcoal is really good at getting rid of trihalomethanes. So, as far as organic contamination is concerned, that these are activated charcoal filter systems work, whether it's under the counter or like I have a Brita filter at home. But it doesn't do anything against the metals and salts.
Yeah.
So, and then, as I said, the problem, well, reverse osmosis as a process is really good, but you basically wind up with an equal volume of wastewater that now has all your contaminants in it. And then where do you dump that? Okay, so that's an issue. Um, so at the end of the day, it really does come down to, and then the problem with some of these other water, they call them water softeners. So basically, they remove all this stuff from the water, and then they add a bunch of stuff. So, and then of course there's the cost, and especially if you have a private well and something's happened to that, it gets really pricey.
Yeah. Let's see, do we have any other questions? Feel free to add your question into the chat, or you can use the raise your hand function.
I think Ned's
Ned?
got another question.
I do. On the question of in-home systems to treat your drinking water, to remove things from drinking water. Um, how is activated charcoal compare with, say, reverse osmosis for things like PFAS? I think most people have will purchase an activated charcoal system because it's there are lots of them and they're not terribly expensive and they seem to be pretty effective in removing most water contaminants. But where does that fit in? I guess two things with radioactivity and with PFAS.
Well, I would put the radioactivity, if it's radium, then it's going to be like barium and strontium, and you're going to need reverse osmosis to do that. So that would work for that. As far as the PFAS, again, we haven't tested anything at this point. And by the way, we didn't. We had an artificial brine that we used, but I didn't put any radium in it. I've got uranyl acetate, which has your depleted uranium, but that's very hot. But as far as the PFAS, that's a good question, and we're not there yet. So I'm waiting to hear, because I'm sure there are a number of companies that are going to be touting their systems for removing PFAS. So, because it could behave, I mean, based on its chemical nature, it could behave as an organic, it could behave as an inorganic because of all those fluoride molecules.
Another call for questions.
Yeah, one last point. We also wound up burning out a pump. We had artificial brine, and it wasn't really that briny, but after 6 months of my student doing these experiments, we literally corroded out a Ryobi pump. So that's another concern of, the diminution of our source water, that yes, there are methods to get rid of the contamination, but the cost and the fact that a lot of the brines from the oil and gas waste is incredibly corrosive. I mean, seawater is corrosive for that matter. But this is much brinier, if you will, and so a lot of these brine treatment facilities that are permitted, especially to treat this, have gone out of business and have literally been abandoned, which is a scary thought. So we had 2 facilities here in Pennsylvania that literally they just turned the lights off, pulled the phones out of the, and turned off the lights and locked up the joint and walked away.
Yeah.
So, that's really disconcerting. And now that kind of waste stream is getting into our source water, and that's not good.
Final call for any questions, comments for John. I think we might be good.
Okay, looks like it's a wrap.
Yeah. Really great discussion. I want to just extend some gratitude to you, John, for an incredibly in-depth discussion. Whenever you were going through your slide deck, I was like taking notes actively. I was like, this is the first time I've heard this and this, so I can like do some like further deep dive. So again, just want to appreciate just want to say how much we appreciate you, extend some gratitude for facilitating our last session. And I also want to extend gratitude to the participants and audience today for joining in, for creating a really great discussion at the end. Yeah, really fantastic. This
Thank you
session
all
is
for
being
attending.
recorded. Yeah, it is being recorded. I will send it out probably later this afternoon or likely tomorrow morning. And I will also send a link to the rest of the recordings for the entire series.
All right. Thank you, Andre.
Thank you, John.
Thank you so much, everyone.
Thank you, Nate. Danny, we'll see you around.
See you soon. Bye-bye.